On RT2-5, we'll combine what we know about area and what we know about special right triangles and circles to find shaded areas. So in my first example, I'm finding just the shaded region. And I'm going to think about what I'm starting with. I'm starting with an entire circle. I know that area is pi r squared. Then I'm keeping just half of that. So I have half pi r squared. And out of that, I'm taking away a right triangle. And a triangle's area will be half base times height. I know this is a 90-degree angle because it is inscribed in a semicircle. So it'll be half of 180 or 90 degrees. And then I see a 30-degree angle. So that is a clue phone to me that, hey, there's a 30, 60, 90 triangle here. My long leg is 14 square roots of 3, so my short leg is 14. And my hypotenuse, which will also double as my diameter, is 28. That means my radius is 14. I have half of a circle, so half times 14 squared pi minus the triangle. Half, my base and height are perpendicular, so I've got 14 and 14 square roots 3. I'm going to pull out my calculator and do some math now. So I've got 14 times 14 divided by 2, 98 pi, gives me my semicircle. And then I have 14 times 14 again, divided in half because it's a triangle. And again, I get 98, and this time the square root of 3 is going along for the ride. One of these has pi, one of them has square root of 3. Those are not like terms. So this is my final answer. We'll do a similar one. I'm looking just for the shaded region. I've got a 30, 60, 90 triangle, and I know that because I see a 60-degree angle, and I can prove this is a 90-degree angle because it's inscribed in a semicircle. I have the entire circle this time, and from there I'm cutting out a triangle. Since my long side is 20 square roots of 3, my short leg is 20, and my hypotenuse, which will double as my diameter, is 40, meaning my radius is also 20. I'll have 20 pi squared minus half times 20 times 20 square roots 3. 20 squared is 400. 20 times 20 square roots 3 is 400 square roots of 3. Half of that is 200 square roots 3. Since one has pi and one does not, this is my final answer. This next one shifts gears a little bit. Now I've got a kite. And I know these will be 90-degree angles because I have a radius and a tangent meeting, and those always meet at a 90-degree angles. So I'm going to have a kite minus 1/3 of a circle. My kite area, we learned that it's the diagonals times the diagonals and then cut in half, and that does work. However, I could also think of it as two right triangles here. And since this is 120 degrees, this becomes 60. And I get a 30, 60, 90 triangle. My long leg is 14 square roots of 3, so my short leg is 14, and I could say, hey, this is two triangles, so 2 times half base times height, which is just base times height. My base and height are 14 and 14 square roots 3. And then I have 1/3 times my circle. My radius of the circle is 14. Times 14. I never remember my 14. It's 196. And 1/3 of that for my circle is going to be 65 and 1/3 pi, or I could have left it as 196 over 3 pi. Either way works. 1 has a square root of 3, 1 has pi. Those are not like terms. I can't combine those, so that is my final answer. Doing another one just like that. Again, I'm going to take this and cut the kite into two 30, 60, 90 triangles. I know that's 60 degrees because it's half of my 120 arc. I know this is 90 because the radius and the tangent always meet at a 90-degree angle. If my short leg is 9, my long leg is 9 square root 3. I have my kite, which is really 2 triangles. So 2 times a half times base times height, which is just base times height. And I'm taking away 1/3 of my circle, 120 out of 360 degrees total. My base and height are 9, and 9 square root is 3. My radius is 9. 9 times 9 square root of 3 is 81 square root 3. 81 divided by 3 is 27. Yes, that felt wrong, but it was right. 1 has square root of 3, 1 has pi. Those aren't like terms, so I cannot combine them, and that's my final answer. On this last example, I know this is isosceles because these are both a radius, which means I know since it's a right isosceles triangle, it's a 45, 45, 90. I have a circle, but I'm only keeping 90 degrees of it. So that would be this much. And then I'm going to cut a triangle off of that. So I have a 4th times, my radius is 12 square root 2. And I'm squaring that times pi. Minus the base and height of my triangle are both 12 square roots 2. Square root 2 squared will be 144 times 2. 288 divided by 4, I get 72 pi. 12 times 12 is 144. Square root of 2 times square root of 2 is 2. The 1/2 and the 2 cancel out, and I get 144. 1 has pi, 1 does not, so they are not like terms, so I get 72 pi minus 144.